Hi, I am ADL Pustozerova, and today I will talk about my work on membership inference attack on neural networks. We use machine learning models in everyday life, but not many people know that these models are actually vulnerable to different privacy and security attacks. Today we will focus on inference attacks, type of attacks when adversary wants to infer some sensitive information about training data having access to the machine learning model. He or she can do this by means of, for example, membership inference attack. The idea of membership inference is to infer from machine learning model if the individual, some particular individual, was in the training set of the model or not. So imagine an adversary and he wants to know if this data sample was in the training set of this target model or not. He starts from querying the target model with this data sample and getting the prediction probability vector, in this case with classes C1, Cn. The next step is to query attack model with this prediction probability vector plus the real label of the data sample. And our attack model already tells the adversary if the instance was in the training set of the target model or not. The question how the adversary trained the attack model. For that, he or she can use shadow models. The idea of shadow models is to emulate behavior of a target model. And by using shadow models, the attacker generates attack model training set. So shadow models are trained on shadow data. Adversary queries the shadow models with this training data, gets prediction probability vectors, labels them as in, queries shadow models with test data or data which was not used for training, gets prediction probability vectors and labels it as out. As you can see, our attack model is basically a binary classifier which predicts in or out depending on the prediction probability vector. And what we want to find here, how prediction probability vector is different for the samples which were used for training and the samples which were not used for training. So the idea of my project is to evaluate how actually membership inference attack is influenced by the complexity of the models, of the neural networks, of their architecture, and the training data size. So the first step was to implement membership inference attack and build the baseline model, which was successfully done. And currently I'm performing this set of experiments to perform an extensive evaluation and drew some conclusions how the architecture of the model actually influences the attack performance. So now we can go to demo. I was using Streamlit to create a web application which will allow to perform membership inference attack. First, you will need to choose parameters for the target training set and the target model. The parameters include such values like target training size, test set size, also the neural network which you want to use. Here I have one layer with target activation function, 64 neurons, and other different training parameters like optimizer or epoch or batch size. Another set of parameters which you need to choose is for shadow models. As I already told you, the models are used to emulate the behavior of target model. In this case, we use similar architecture as a target model. And the last set of parameters is attack model. Let's start membership inference. First, we need to train our target model on the target data. And here you can see I already trained it. And we have accuracy on the training set 100%, accuracy on the test set only 7%. But this is a quick example. Our data set, by the way, contains here 100 classes. So this is why 7%, not such a bad performance. So then we're training shadow models. After we train shadow models, we are able to generate training set for attack model and to train our attack model. Here you can see that our attack model has 83% of accuracy on training set and 98% precision and 67% accuracy on the test set with 80% precision. Let's investigate how membership inference attack performance is influenced by the complexity of our target model. So the idea here, the hypothesis will be that the more complex our target model, the more information our target model can remember about training data. That means that our membership inference attack accuracy should increase too. So let's see if our hypothesis holds or not. So now we're training our target model.
A few moments later.
Nice. Now we have results of our membership inference attack. And as you can see, now our test accuracy actually increased. So from our experiments, we could tell that the neural networks with larger number of neurons are more vulnerable to membership inference attack. Currently, I'm working on expanding the set of my experiments to find out if more complex neural networks are more vulnerable to membership inference attack and therefore more vulnerable to privacy risks.